In this video, we are going to talk about domain and range of functions. Domain is the set of all possible input values, which are mostly x, and range are all possible output values, which is mostly y. And this variable can change depending upon the function. Let's do some example. Let's do y equals 1 plus x squared. Here, this is a parabolic function which is shifted to 1 unit in the positive y-axis. So the domain for this function would be all possible x values. Here, we can input any value of x. There is no restriction for us to put a value of x. So the domain would be all values of x. Now, we need to represent this in an interval notation, which would be all numbers of x from negative infinity to positive infinity, which basically means all values of x. So we can write this as a notation which is from negative infinity to positive infinity using parentheses. And the range of this function would be the set of all possible y values. Now we know that square of any number could be 0 or positive, or any positive number. So the output value has to be 1 or greater than that. So the range would be 1 or more, right? 1 or any number greater than that. And this can be written as 1 to infinity. Now here we are including 1, and 1 is not an unbounded like infinity, so we use square bracket. Let's do another example. Let's do g of t equals square root of t minus 3. Here, the input is t, which is similar to x, but is written in form of t, which is usually represented by time. But the concept remains the same. So the domain for this function would be all values of x, of all values of t, should be t, which keeps this function, this t minus 3, positive, because we cannot have a radical of a negative number. So we want a domain, or we want the input that keeps t minus 3 greater than or equal to 0. And then if we simplify this by adding 3 on both sides, this would give us t greater than equal to 3. So the domain would be any number from 3 to infinity. And again, since we are having this equal, we are including the 3. And so we are using the square bracket. Now range for this function would be the possible values for g of t. Now, no matter what value we put in for t, the output would either be 0 or any other positive number. So the range would be from 0 to positive infinity. So let's do one more advanced problem. Let's try to find domain and range for y equals 2 over x squared minus 16. Now finding domain for this function, since this is a fraction, the denominator cannot be equal to 0. That's the only restriction that we have here. So Let's find the values where the denominator is 0. So let's set x squared minus 16 equal to 0. So let's add 16 to both sides. This would give us x squared equals to 16. And then square root both sides. This would give us x equals plus minus 4. Right? So the domain for this function would be all x values except when x equals to 4 or negative 4. And so to write this, we can start from negative infinity, and then we are not including negative 4. And now we use union when we have more than one data set. So union from negative 4 to 4, we're using parentheses since we're not including the endpoints. And then again union from 4 to infinity. Now this notation includes every number of x except negative 4 and 4. Okay, the challenging part here would be finding the range of this function. It's really hard to visualize what values of y are possible. So another way of doing is converting the original function into an inverse function where we switch x with y and y with x. And then find the domain of that. Because finding domain is usually easier. So, when we find domain of the inverse function, that would actually be the range of the original function. And that's what we're going to do here. So the inverse function for y equals 2 over x squared minus 16 would be x equals to 2 over y squared minus 16. And we have to simplify this function in terms of x. So we'll multiply y squared minus 16 on both sides. And the y squared minus 16 here gets cancelled out. And we are only left with 2. And now we distribute this x. That would give us x times y squared minus 16x equals 2. And now we're isolating the y term. So we add 16x on both sides. And that would give us xy squared equals 2 plus 16x. And then divide both sides by x. And then square it. So the function that we get is y equals to square root of 2. Sorry. The function that we get is square root of 2 plus 16x over x. Now we have to find domain for this function. Now we know that this is a fraction and the denominator of fraction cannot be equal to 0. So the one constraint that we find is x cannot be equal to 0. Other thing is that this whole function cannot be negative since it's under a radical. So we want 2 plus 16x over x to be greater than equal to 0. Right? So 2 plus 16x has to be greater than equal to 0. And since we multiply x on both sides, this is what we get. And then subtract 2 on both sides since we're isolating for x. and then divide 16 on both sides. And then we simplify this, that would give us negative 1 over 8. Another thing to keep in mind is that any value of negative x would make this whole function negative, since we have separate x in the denominator. So x also has to be greater than 0. So those are the three constraints that we have. X cannot be equal to 0, x has to be greater than equal to negative 8, and x has to be greater than 0. So the domain for this function would be all the value from negative infinity to negative 1 over 8, and we are including negative 1 over 8, and a union from everything but not 0 to infinity. Here we are including negative 8 and anything smaller than that, and we are excluding all the numbers from negative 1 over 8 till 0, and then we're including everything from 0 to infinity. And this is actually the range of our original function, and that's what we were looking for. And so this is the domain of the function, and range would be from negative infinity, negative 1 over 8, union of 0 to infinity. And this is what we just calculated. That's all for this video. Thank you for watching.